Hi, I am Arshidhar Sena, and this presentation is for assignment 2 for the subject Advanced Computer Networks under MSc in Information Technology, conducted by Sri Lanka Institute of Information Technology. This presentation is based on a hypothetical network, and the network design and implementation will be explained. And the hypothetical network is based on a university student housing IT network. The group members are Indika, Kasun, Harsha and Laksha. Then we'll move on to the agenda. First of all, let's look at the overview of the university student housing, then the site layout of the university, then the basis of design, which explains the basic network infrastructure of different buildings, and bill of quantity explains the bill of materials for the hypothetical network, then the network sizes given from this hypothetical network, then finally logical network diagram. Let's start with the overview of the university student housing network. This hypothetical university basically provides accommodation for university students and staff. There are 4 main types of buildings in the university: residence halls, university apartments, residential computing center and utility buildings. Residence halls are also known as dorms or dormitory, are for individual students, and for the university apartments are for university students which have children or a family. And the residential computer center is basically has the computer lab, and it has the core network of this hypothetical network. And the utility building has the outdoor structures such as storage, workshops, office, gyms and playhouses and etc. Then let's move on to the site layout. The university housing IT network comprises the following buildings: the residential computing center building, utility building, apartment building. There are 3 apartment buildings and 2 residence hall buildings. Next, this diagram shows the site layout of the hypothetical university. As you can see, the apartment buildings and the residence buildings are pretty larger than the utility building. The RCC building or the residential computing center building has the core network of this hypothetical network. Then let's start with the basis of design. First, the RCC building. The RCC building has the core of the IT network with distribution switches in each of other buildings connecting to the core switches. To incorporate with that, there is one main distribution frame closet on the ground floor and 2 intermediate distribution frames in first floor and the ground floor. The rest of the presented slides will be presented by Kasa.
Thank you, Harsha. And now we are moving to the utility building. Utility building in architecture. Utility building is the smallest building which having one IDF at the ground floor. This building is to be considered as a logical extension of the RCC building's distribution block. Now we are moving to the apartment buildings architecture. These apartment buildings will be like this. This building having 3 separated floors which carrying more crowd. So according to their requirement, we have analyzed and decided to have 3 IDFs to the building with structured cabling, 1 IDF per floor, and the ground floor IDF will act as the MDF to the building. These apartment building and utility building both will be proposed to connect to the core network. Now we are moving to the residence hall building architecture. So we according to our analyze, this residence hall is also more important building to the network, because the building also having 3 IDF with structured cabling. This building is also 3-story residence hall building. So we have decided to have 1 IDF per each floor according to the requirement, and we propose to have 1 IDF in ground floor which act as MDF to the whole building, and this building is also connected to the core network according to the plan. Now we are moving to the vendor selection criteria. We have considered more areas when selecting vendors to buy the bunch of materials. First thing is single vendor advantage. This reduces the incompatibility of the network equipment connected to the network. And we have considered the areas which after sales support and maintenance of the network will be easy from using one vendor. And we have considered stability of the vendor in local and the global market. And we have considered the response time and the minimize the downtime of the network. And we have mainly considered the availability of the system integrators and the partners and spare part depots in Sri Lanka. We have listed many competitors at vendor list as Cisco, Juniper, IBM, HP, Arista and Fortinet. And now we have selected Cisco after a careful consideration at each point we mentioned. Now we are moving to the BOQ. In this BOQ, bill of quantity, we have descriptively quantifying what we have going to use at the architecture, network architecture. Now we are moving to the design tools what we have used in this designing part. Cisco Dynamic Configuration Tool and the Cisco Feature Navigator tool and the Microsoft Visio 2007 for diagrams and the Visio stencils for device icons to draw the design. In IP addressing plan will be discussed by Indika Kumara. Thank you.
Thank you, Kasun. I'm Indika Kumara. Rest of the presentation slides will be explained by me. And in here we are going to discuss about the IP address plan we used here for the network design, and mainly we were planning to use 10.53.0.0/16 subnet for the overall network, and again the main subnet will be further subnetted into smaller ones. And we initially decided to use separate subnets for different buildings. For each building, maximum number of host IP addresses will be less than 2000 IP addresses, so we plan to have 2000 IP addresses per subnet. So therefore we further divided into /21 subnets, which represent the first 21 bits for the subnet address and the rest of the bits for the host. So for example, RCC building has 10.53.128.0./21 subnet, which supply the 2000 averagely around 2000 IP addresses. So next slide is about use, technologies and concept. Mainly we used network virtualization in this our network design. Network virtualization achieved in terms of two methods. First, we use virtual LANs, which means VLANs, for the separation of network segments, which means isolation of broadcast domains achieved by VLANs, as well as separation of traffic as well. Again, rather than using two separate networks, we decided to segment them to two logical networks by using virtual device context in the core switch. So core switches equipped with the virtual device context, and again for the structured cabling has used in the network designs. Mainly we use ITU standards, and that means for the copper cables less than 100 meters length has taken, and proper patch panels, and as well as the connectors used according to the network standards, cabling standards, and the hierarchical model used for the switch fabrics. We used core switches, distribution switches, access layer switches. So therefore we divided it to core layer, distribution layer and access layer, and mainly Nexus 7000 used for the core layer, and the Nexus and the Catalyst 4000 series used for the distribution layer, Catalyst 3000 series used for the access layer. And the inter-switch communication mainly equipped with 10 gigabit Ethernet to maintain the bandwidth requirements between switches and reduce the serialization delay. And the virtual port channel used for the switch failover and the redundancy mechanisms, and it has improved availability of switches and services. And the ETH channel technology is used for the link redundancy between switches as well as the server hosts and switches. And the interior gateway routing protocol we used here named as OSPF. So OSPF mainly selected for the rapid convergence when there is a failure in the network routing. And the quality of service technology is used here for the prioritization and the deprioritization of particular network service traffic. And the network management services used here for the management and monitoring and the optimization of the network. So mainly the SNMP protocol used here for the NMS systems. And the multicast technology is will be implemented here for the CCTV video surveillance systems. So in their protocol independent multicast pass mode will be configured as the technology. And the network services mainly for the facilities management management work. So there are around 7 facilities management services First one is green kiosk systems. Green kiosk mainly implemented to manage kiosk systems installed in different buildings. So green kiosk means usually it's targeted mainly for the software downloads, and as well as the application services mainly based on the internet. And room touch screen services, this is mainly for the light control of the rooms by using touch screen services, and the lighting control system for the building management lighting control. And there is a separate service named building management to maintain the electrical and mechanical systems like AC systems, air condition systems management. And the digital addressable fire alarm systems will be installed here as another network service. And the access control systems for the access card services of the students and staff to enter into particular building premises. And the video surveillance will be achieved by CCTV video services implemented as a network service in here. And next, the logical network diagram. The logical network diagram I introduced here will be mainly consist of 3 switch layers. As I said previously, we implemented Nexus 7000 series switches for the 2 switches for the core layer, and those network 7000 series switches connected to the server farm switches situated in the RCC building, which is the same premises that core switches situated. And the core switches again connected to another 4000 series distribution layer switch of the same building, as well as the different buildings also contain at least one distribution layer switch, which is called Cisco 4000 series. In here we selected only single switch with redundant power supplies and redundant supervisor engines in the switches, which means the switch control plane will be duplicated with 2 supervisor engines, and switch power management will be installed as 2 separate power modules. So one power module fail, it will take over by another one, so full redundancy available in the single chassis. And next, distributions layer switches has connected to access layer switches in each building, and the utility building has only one access layer switch, and it connected to the RCC building distribution layer switch. And additionally, there is a server farm switches. There is a server farm as well. This server farm contains Nexus 5000 series switches. Those are 10 gigabit Ethernet switches, mainly connected to the core layer switches, which are Nexus 7000. And additionally, fabric extenders, which are Nexus 2000 series fabric extended connected to Nexus 5000 for the connectivity of 1 gigabit Ethernet servers. And there are 2 firewalls connected to core switches, and those switches again connected to Quality Future Network Vantage switches. Again, there is a building central monitoring, central building management position, which is outside the premise of this location. So mainly CCTV traffic will be monitored there as well. So it main switches connected to that particular location for the monitoring purpose only. So mainly the network logical network design is something like this. So in hereby I like to take further comments if there are such modifications required for the further improvement, and I must thank very much for my group members as well as the senior visiting lecturer, Mr. Tilak Silva as well, and I gained a lot of knowledge by developing or designing this network by practice and as well as the assignment base. Thank you.